Today, let us revise some of the important questions which have been repeatedly asked in the board examinations. Let us start from the first chapter, Chemical Equations and Reactions. First question, when a copper wire is left in silver nitrate solution, it is observed that the solution turns bluish green color. So this question is one of the important board examination questions. Such type of questions you can expect. These are trickiest questions actually. Now we have to answer two important subdivisions. One thing about the observation, what we have observed, we have to write that in a sentence. And then we have to provide the equation, chemical equation. So first thing is about observation and second thing is about chemical equation. Now let's get back to the question. First, always try to comprehend the question properly. Otherwise, you can't present a solution for that. Now, let us look into the question. So this is copper, right? In this question, they have provided two important reactants. One is copper, the other one is silver nitrate solution. We are all aware of that, right? Fine. But can you able to see one thing? They haven't provided the product name. The product name is yet to be revealed. So we have to work out this experiment. Then only we can come to the conclusion as to what product is formed. Then only we can provide a chemical equation for this. It might appear to be simple, but still it's not simple. You have to work out the experiment first, then only you can draw the conclusion out of that. Now let us proceed with the experiment. Take a beaker. Now I'm going to add the silver nitrate solution. The color whatever I use is used for acids or whatever substance. No, it is only for the representation purpose, just for the understanding purpose. It doesn't mean that the color whatever use is same to that of the original product. So don't get confused with that. So this is a silver nitrate solution. Now let us take copper wire. This is copper wire. Now what am I going to do is I'm going to dip this copper wire inside the silver nitrate solution. This is what the experiment is all about. Now we have to wait and watch. Yes, we saw. You can able to see a change in color in the solution. Can you able to see a bluish green color solution? But still we don't know what the product is all about. Now we have to work out the experiment. So now the experiment is over. Now we have to provide a conclusion for this. So this bluish green color is what? First write the word equation. Copper combines with silver nitrate solution. So this in turn produces a bluish green color product. So what product is formed? Copper nitrate is formed. But how copper nitrate is formed? Here we have to understand the reactivity capacity of the element. When you compare to that of silver, copper is more reactive. Copper is more reactive. So what copper does is it displaces the silver and accommodates its place. So now the silver is left alone. The product which is formed is copper nitrate. Along with that, silver is also present. Silver is also formed. Now we have to convert this equation into this word equation into a normal equation. Normal equation in the sense we have to make use of lots of formulas and symbols. Now let me write the normal equation for this. So what is the symbol for copper? It's Cu. What is the symbol for silver nitrate, I mean formula for silver nitrate. So this is a formula for silver nitrate. And copper nitrate, let me write here in the equation so that you can understand it better. So copper reacts with silver nitrate, as I already told you, because of the reactivity power, copper replaces the silver position, and it led to the formation of copper nitrate. Along with that, the silver is also present. So here silver is left alone. So this copper gets accommodated here and forms something called copper nitrate. It's nothing but a bluish green color compound. So that bluish green color is because of this compound, copper nitrate. It's important that we balance the equation once we complete it. So here if you say copper, it is already balanced, right? What about silver? Silver is also balanced, but what about this nitrate? Nitrate is yet to be balanced. So here it is 2, right? So if here we should mention 2. So this 2 will also be for silver. So here we should also balance the silver. So this is the entire experiment. This is how we have to provide an answer. Now let us move on to the next question. A light-sensitive compound X of silver is used in black and white photography. On exposure to sunlight, its color changes to gray. So this is a question all about, and they've asked in this question twice, one in the year 2014, the other one in the year 2011. Fine. So here we have to satisfy 3 important subdivisions. One is we have to identify the compound. If you see the question, if you read the question once and twice, you can able to conclude one thing. They didn't mention the name of the compound. So it's one of the most trickiest question, right? They didn't mention the name of the compound. And they have mentioned about the application of that compound, which means that particular compound has something to do with silver. Maybe silver might be one of the element in that compound. And it is used very often in the black and white photography. So what will happen if that compound is exposed to sunlight? Its color changes to gray. Fine. We have to mention the chemical reaction. Then we have to convert that chemical reaction into chemical equation. Then we have to balance it. Then last but not least, we have to mention the type of chemical reaction. Fine. So this is the entire question all about. If you couldn't able to understand the question, please always do read the question once and twice. Sometimes we might get confused, right? And during board examinations and all, you will be very tensed. So don't get confused with the question first. Take some time to read the question first, then you can go and pen down your solutions. Now, we have to find out the x. So what could be this x? Any any guesses what could be this x basically? How can we find this x? We all know silver chloride is used in black and white photography. So if we subject the silver chloride to sunlight, so in the presence of sunlight, when it is exposed or subjected to sunlight, the color of silver chloride changes to gray in color, right? So what could be the reason behind it? What type of reaction it is? It changes into gray color. This is very simple. The silver chloride undergoes a process called decomposition. So it undergo a process called decomposition. In fact, if I need to go for even more scientific terminology, it is called as photolytic decomposition. It's called as photolytic decomposition. So photolytic means what? Photo means light. So let me break this terminology. So photo means it's light. It's sunlight. So here we are exposing that compound to sunlight, right? So light means it's photo. Lytic is breakdown. So lytic means what? Breakdown. So lysis, you would have heard about the word lysis in biology. Lysis means what? Breakdown. So this is called as photolytic decomposition. Photolytic decomposition. Now let me pen down the equation for this. We have found the silver chloride compound. Fine. Now we also found the type of chemical reactions, nothing but decomposition. If I need to go even more specific, it's called photolytic decomposition. Now it's important that we mention the equation. So here, when silver chloride undergoes decomposition, it forms silver and chlorine. So chlorine is in the form of gas. Now we have to mention the equation. So let us pen down the equation now. So how can we write the equation here? Fine. Write the silver chloride. So this is silver chloride. What happens? So on exposure to sunlight, so what happens? On exposure to sunlight, it breaks down and form silver plus chlorine gas. So it is in the form of gas. That's why I've written Cl2. So gas means it's understood, right? Chlorine is in the form of molecule. That's why I'm mentioning here CO2. Now it undergoes a process called photolytic decomposition, or you can, in simpler terms, you can call that as decomposition itself. So what is decomposition? A single product breaks down into one or more reactants. So this is one reactant, silver is one reactant, and chlorine is one reactant. So in the presence of sunlight, that's why I called this as photolytic decomposition. So this is how we have to write the equation. Now we have to balance the equation. It's very important. Now we know silver is balanced, Ag. What about chlorine? No, it is not balanced. Here it is 2. So we have to mention here 2. So this 2 is nothing but a coefficient. It should always be present at the front of the element. And this 2 is not only for the chlorine but also for the silver. So again here we should balance the silver. It is nothing but 2. So again we should balance the silver. It's 2. Now this equation is said to be balanced. Let me write the balanced equation here. Silver chloride. So this is a balanced equation. Now the equation is said to be balanced. So this is how we have to pen down the chemical equation. First, we have to find the compound, then we have to find the chemical equation. We have to write it in the form of word, then we have to convert that into a normal general equation. Then we have to mention the type of chemical reaction here. That's it. So if you satisfy all these 3 questions, then your marks will be rewarded by the examiner. No doubt, sometimes we might go wrong in balancing the equation. So always make sure that if you balance one compound, immediately you should look on and count for the other elements as well. Sometimes you won't count the other elements. So ensure that RHS is equal to LHS. Fine, which means the reactant and product should be The number of atoms present in the reactant should be equal to that of the number of atoms present in the reactant. So it's nothing but we all know how to balance the equations. Law of conservation of mass, that's an underlying principle behind it. Fine. So this is how you have to answer such type of questions. It's very important. Why does the color of copper sulfate solution change when an iron nail is dipped? And this question has been asked twice in the board examination in the year 2012 and 2015. Now, how can we answer such type of questions? The first and foremost thing is read the question once and twice before arriving a conclusion. It's important that you read the question. Here, if you see the question, they haven't provided the color of the copper sulfate solution, right? This is just a general statement. They just gave the general statement that the color of the copper sulfate solution will change when it reacts with the iron nail. But they haven't mentioned the color of the copper sulfate solution. We have to know the color of the copper sulfate. So we all would have seen in the chemistry lab, we used to do lots of tests, right? So what is the color of the copper sulfate? It's nothing but blue color. Now let me draw two test tubes. This experiment doesn't require two test tubes. Just one test tube is enough, but the reason why I'm taking two test tubes is just to show the change of color. Now, let me consider this as first test tube and this as second. Now, we all know the color of copper sulfate, right? So what happens if you dissolve the copper sulfate in water? It becomes blue color solution. So let me take blue color solution, that is the copper sulfate solution in the test tube. So this is a blue color solution, copper sulfate solution. Now let me take the iron nail. You all know the color of the iron nail. It will be something like a grayish in color, right? So this is just an iron nail, so it will be a gray in color. So now what am I going to do is I'm going to dip this iron nail inside the copper sulfate solution. So it will be completely immersed. Okay. So like that we have to immerse the iron nail. Now we have to observe some time. You can able to see a change in color. After some time you can able to see a change in color. The color of the solution would have changed into green color. You can able to see a greenish solution now. At the same time, even the iron nail color gets changed. You can able to see a red brownish color coating on the surface of the iron nail. So this is what the entire experiment all about. Now we don't know the name of the compound which has been formed, right? So let me write the equation. First always pen down the word equation, then you can convert that into a general format. So this is the entire setup. Now let me write it. Copper sulfate is reacted with iron. So basically here we are using iron, so that's why I'm mentioning here it has iron. You need not have to mention iron name or not. Now it led to the formation of a new compound which is greenish in color. Now what could be the name of the compound? It's quite simple. Now what this ion will do is it will displace the copper and form something called iron sulfate. And this copper is left alone. Now the greenish color is due to the presence of this iron sulfate. So iron sulfate is responsible for that greenish color. And copper sulfate, as we all know, it's blue color, right? Now what could be the reason of this reddish brown color coating in the iron nail? Very simple, it's copper. Now this is what the entire reaction is all about. This red brown layer is basically, if you see the red brown layer on the surface of the iron nail, is basically due to the copper metal. And this light green color solution is due to the formation of iron sulfate. So this is what the entire reaction all about. Now we wrote the reaction. Now we found the compound name, but we are yet to explain the mechanism behind this. Why iron has to displace the copper? Why? Is there any reason behind it? Yes. So now let us look into the reason first. Before talking about the displacement, let me talk about the important theory, that is reactivity. So in this first chapter, we all would have learned about reactivity. So what is reactivity all about? Why we have to learn it? It's very simple. The elements are arranged in certain order that completely depends on their tendency to react. So they are arranged in such a way where they have the ability to react. So let me write those elements, and let me write those metals name, which are highly reactive and which are least reactive. There are some metals which are highly reactive when you compare to that of metals which are low reactive. So it has always been written in a descending order. So let me write the metal which is highly reactive first. Then let me mention the metal which is least reactive. So this is very important. This reactivity series is very important because most of the equations, if you take, not equations, but most of the chemical reactions, if you take, the underlying principle behind most of the chemical reaction is this reactivity theory only. So the elements are most of the time arranged in a decreasing order of their reactivity. Now let me write. First let us start with potassium. So potassium, so we all know it's K. Sodium, barium, calcium, magnesium, aluminium, zinc, iron, and nickel. So if you take these 9 metals, they are considered to be more reactive than hydrogen. So these 9 metals are more reactive. They are more reactive, which means if they combine with any elements or any metals, they can easily displace it. So these are the highly reactive metals when you compare to that of other metals. So they are most reactive. In the entire reactivity series, if you take, they are most reactive metals. So this is about highly reactive metals. Can you able to see the iron? So now let us come into the question. Can you able to see the iron? So iron is considered to be highly reactive, right? So they have been considered as a highly reactive metal. So this is basically a reactivity series. We can also call this as activity series. Now let me write the elements which are least reactive. So what are the elements which are least reactive? Copper, mercury, silver, gold, and platinum. So these are least reactive metals, which means when these metals combine with any other metal or metal which belong to highly reactive category, they will be easily displaced by those metals. So these are least reactive. So this is what the entire reactivity series is all about. So the elements are most of the time arranged in a decreasing order of their reactivity. So this is what we have to understand first. Now, if we look into this equation, now let me pen down the general equation about copper sulfate. So it is in the aqueous form. So at the end of the equation, we can write the state of the matter. So iron forms something called iron sulfate plus copper. So this is what the entire reaction all about. So once you are done with the equation, always check whether the equation is balanced or not. So from this itself we can able to see the equation is balanced only because one copper, yes, the copper is balanced, sulfate is balanced, I mean sulfate in the sense sulfur oxygen is balanced, iron is balanced, so we need not have to balance this equation. There is no need to balance it. Now it's important that we mention the state of the compounds. This is in the aqueous form, ferrous sulfate, and this is in the solid form. You all know. This is again in the aqueous form because we took copper sulfate solution, right? So it will always be in a aqueous form. And this is in the solid state. Now we are done with the equation. We also know the reactivity series, but still we lack something here. Can you guess what type of reaction this could be? Here, only one element has been displaced. So this copper is alone kicked out. This copper is alone kicked out by this iron. So only one element is displaced. Normally, this is called displacement reaction. So in previous slide, we saw what is the decomposition reaction, right? So these are type of chemical reactions. So this is called displacement reaction. And there are single displacement and double displacement reaction. It completely depends on the number of elements that has been displaced. So if you take here, the iron has displaced the copper. So only one element has been displaced. So that's why it is called a single displacement reaction. So this is how you have to present an answer. All these points has to be there for this question. Write the type of chemical reactions in the following. Yes, here they have already provided two important subdivisions. One is rusting of iron, the other one is the reaction between acid and base. Here they didn't ask you to write any chemical equations. They have just asked you the type of chemical reaction. So this is a normal process, right? In day-to-day life, we very often see about the rusting. It's quite common for us to view rusting, right? I mean, normally, what is the other name for rusting we normally call as? Corrosion. So corrosion. You can able to see this very often. Now they have just asked us to pen down the chemical reaction alone. So what sort of chemical reaction does rusting of iron can be categorized into? Yes, it's very simple. It comes under redox reaction type. So redox reaction is nothing but, if I need to explain about it further, redox is a combination of reduction and oxidation, which means the reduction and oxidation takes place simultaneously. So that's why we call that as redox reaction. Now, what happens during the rusting of iron? What happens? How that brownish color is formed? It's very important, right? We have to know about it. How that red brownish color is obtained? First, let me write the word equation for this. Iron. So let us take iron. What will happen if iron is made to react with oxygen and water? So what will happen if it is made to react with oxygen and water? So this oxygen, normally know, it is present in the atmosphere itself. So if the iron rod is exposed to atmosphere, no, at one point of time it will start to corrode. So the oxygen is already present in the atmosphere, so we do not have to worry about that. And what will happen if it is exposed to water as well? So this oxygen and water, what impact it is going to create on this iron? How can we continue with this equation? So what is a final product we are going to get here? It's very simple. Hydrated iron 3 oxide. So hydrated iron 3 oxide. So this is what responsible for that brownish color. So initially, if you take any nail, okay, let me take iron nail itself as an example. So this is a iron nail, right? So this is a iron nail. Normally iron nail looks like somewhat grayish color, right? So now at one point of time, when it is exposed to atmosphere, it will undergo a process called corrosion, and just now I explained you how the corrosion is taking place. So once it is exposed to corrosion, it color turns into reddish brown color. So this hydrated iron oxide is responsible for providing this reddish brown color. So this is how the word equation look like. And formula, we know how to write the formula. The iron is Fe plus oxygen plus water, and it gives something called hydrated iron 3 oxide. So hydrated, we have to know, hydrated means what? Water. So first let us write the iron oxide. Fe2O3 is iron oxide, right? So first write that. This is iron oxide. Along with that, hydrated means what? As I already told you, hydrated is nothing but water. So just write water and mention your n. I mean, here n is nothing but the number. So this is what? This is how the formula look like. And we need not have to mention the formula, we need not have to write the reactions and all. It's enough that we mention the type of chemical reaction alone. Sometimes they might ask you to pen down the reaction. So in that case, you should be able to write this entire reaction. You should be able to write this entire formula. Then only you will be rewarded with full marks. Now, as far as first subdivision is concerned, we have learned how to write the answer. Now let us move on to the second subdivision. Reaction between acid and base. Yes. So what is a chemical reaction? What is the name of the chemical reaction between acid and base? Normally what we call that as, yes, what we can call this as, this is acid and this one is base. Now I'm going to react this acid and base together. What will happen? If acid and base react together, what it will happen? It will form salt plus water. So this is a general format. If acid reacts with base, it forms salt and water. So this is a general format. Now there is a name for this reaction. What is the name for this reaction? Normally we call this as acid base reaction, and we can also call this as something in other term, that is neutralization. So this is otherwise called as neutralization reaction, right? So we can also call this as neutralization reaction. So neutralization reaction, what will happen? The acid combines with base and forms salt and water. So this is a general format. Let us learn this neutralization process with some example so that you can understand it better. Let me take any acid and react that with sulfuric acid, and we'll see what type of salt we are getting out of that. Fine. So sulfuric acid, first always write it in the word equation for on a safer side. Then you can convert that into a formula. So sulfuric acid, when it is made to react with calcium hydroxide, so what will happen? It will form something called calcium sulfate. Is there any other product formed apart from calcium sulfate? Yes, it's water. I told, right? So here sulfuric acid is acid and calcium hydroxide is base. So when acid and base react together, it forms a salt. So this calcium sulfate is a salt and this water is just a water, right? Symbol. We can write the symbol better. Now we have to convert this word equation into a general chemical equation. We know the formula for sulfuric acid is H2SO4 plus. So what is the formula for calcium hydroxide? CaOH2. It's hydroxide, right? So normally OH. So base will always form OH, hydroxide ions, and acid will always form H plus ions. So H plus ions. Fine, right? So now what will happen? Now it forms something called calcium sulfate plus water. Now always look whether the equation is balanced or not. If not, you have to balance the equation. Is here hydrogen, hydrogen. Here it is 2. Here it is 2. Yes, it's balanced. What about sulfur? Yes, it's balanced. What about oxygen? Here 4. 4 plus 1, 5. Here 4. What about the oxygen which is present inside the hydroxide form? There it is 2, right? So 4 plus 1, sorry, 4 plus 2, it's 6. So here there are 6, but here there are only 5. We have to balance it. What about calcium? Calcium is balanced. Now we have to balance the oxygen. So if we have to balance oxygen, obviously the hydrogen will also change the number of atoms. Again, you have to count it. So mention here 2. So if we mention here 2, I think the entire equation is balanced now. So just multiply the, this is coefficient, right, as I already told you. Let me tell you again, this is a coefficient, this is a subscript. Just multiply the coefficient subscript. So here hydrogen is 4. So the number of hydrogen atoms here is 4. What about the number of hydrogen atoms here on the reactant side? Here it is 2. Here inside the hydroxide we have 2, right? So totally 4. Now, what about the oxygen? Oxygen again, this 2 this 2 will also go for oxygen. So this 2 is not only meant for the, actually the purpose why we mentioned here 2 is to balance the oxygen, right? So to balance the oxygen we mentioned here 2. So this 2 is also for hydrogen as well. So now here 2 oxygen, and here it is 4, 4 plus 2, 6, 7, right? So 4 plus 2 is not 7, 6. I'm sorry, 4 plus 2 is 6. So here 6. What about here? 4. What about the oxygen which is present inside the hydroxide form? Here 2, right? So 4 plus 2, 6. Now the oxygen is balanced. Fine. What about the calcium on the reactant side? It's 1. What about here? Here is also 1. So again the calcium is also balanced. So this is on the LHS side and this is on the RHS side. So this is how we have to balance the equation. What about sulfur? Yes, that is also balanced, 1, 1. So this is how we need to balance it. Again, see the question properly. They didn't ask for the chemical equation. They didn't ask for any examples. They didn't ask for any chemical reactions. They have just mentioned the type, which means they have just asked the name of the reaction. So when acid combines with base, it forms salt and water. This is nothing but acid-base reaction, or we can call this as neutralization reaction. So normally it is referred to as neutralization reaction. Fine. Yes, this is how you have to answer for such type of questions. Manganese dioxide reacts with hydrochloric acid and form manganese chloride. Fine. So this is one reaction, chemical reaction, and what they have asked us to do is we have to convert this chemical reaction into chemical equation. We have to pen down that as in the form of chemical equation. Fine. So we know the reactant name. So what is the first reactant? Is manganese dioxide. What is the second reactant? It's hydrochloric acid. What it forms? So the product here is manganese chloride. Fine, the product here is manganese chloride. Always write the word equation first, then we can go ahead with the general chemical equation format so that you won't get confused anymore. First write the reactant. So as I already told you, the reactant should always be written on the left side of the chemical equation. So manganese dioxide let me write again. So if this manganese dioxide reacts with hydrochloric acid, it forms manganese chloride. And it not only forms manganese chloride, along with manganese chloride, there are some other products that are also formed. One thing is water, and chlorine. So chlorine is in the form of gas here, it will be liberated later. So this is how the word equation first look like. Then convert all these words into formulas. So always write the formulas. So how can you write the manganese dioxide? Mn is manganese. Most of the time, no, students get confused between Mn and Mg. Mg is magnesium. It's not manganese. So Mn is manganese. So manganese dioxide. So 2. 2 is nothing but here di. That's why we are calling this as manganese dioxide. Then we have to write the hydrochloric acid formula. HCl we all know. How to write manganese chloride? MnCl2. So this is how we have to write manganese chloride. And water we all know, H2O, and chlorine Cl2. So it is gas in the form of gaseous state, right? That's why I'm mentioning here too. So gas, no, it will always be in the chlorine is in the form of molecule. Fine. Now it's time for us to convert this into chemical equation in a general format where we make use of all these symbols. So we have to replace the word with all these symbols. Fine, let us write now. Manganese dioxide plus hydrochloric acid gives manganese chloride plus water plus chlorine. So this is what the entire reaction all about. So two reactants combine together to form a product. So these are the products. Now, whenever you complete the equation, remember one thing. Check once and twice that it's balanced or not. Look for manganese. Here, if you look for the manganese Mn, so yes, it's balanced. We need not have to balance it. It's already balanced. What about oxygen here? 2 oxygen. What about the number of oxygen atoms here? Here, how many? It's had to be balanced, right? It's had to be balanced. Remember one thing when it comes to balancing the equation. Always keep hydrogen and oxygen at last. So here again, hydrogen is said to be balanced, right? Can you able to see? Here only one, but here it's two. What about chlorine? Chlorine is again yet to be balanced. So as I already told you, always give importance for hydrogen at last. So now let us balance the chlorine. So how can we balance the chlorine? Yes, it's 2 here, right? So what can we do here? How many here? Count the number of chlorine. Count the number of chlorine atoms on the left side and as well as on the right side. Okay. So if you count the number of chlorine atoms on the right hand side, how much? How many? It's 4. So here 2, here 2. It's totally 4. So ensure that you write here 4. So this 4 is not only for the chlorine but also for the hydrogen. This is we are making changes in the coefficient, not in the subscript. We should make use of the subscript while balancing the equation, but we shouldn't make any changes in the subscript. This is subscript. We shouldn't make any changes. We have to make changes only in the coefficient. Coefficient is always written at the front of the formulas. So this 4 is not only for this chlorine but also for this hydrogen. But if you look into here, again you have to balance, right? Again the hydrogen has to be balanced here because here it's 4. Now the chlorine is balanced. What about hydrogen? Again you have to count the number of atoms on the left side and as well as on the right side. Again you have to balance it. So now how can we balance this? What number we can mention here? So if I mention here 2, if you multiply subscript and coefficient, it accounts to 4. So now hydrogen is also balanced. So manganese is balanced, hydrogen is balanced, and chlorine is balanced. And what about oxygen here? We should this 2 is also for the oxygen. Can you able to see this 2 is also for oxygen as well. So here is also 2. Here is also 2 oxygen. Yes, fine. 2 oxygen atoms. Yes, fine. Now this entire equation is balanced. So whenever in board examination, if they ask about like this chemical reaction, if they ask you to convert those chemical reaction into equation, you have to write like this. This is how you have to write. So don't always get into the formula. If you are confident with the formula, you can get you can write that straight. But if you are not okay with the formula, always go with the word equation first, then you can write the formulas. So this is how you have to write, and ensure that you balance the equation, because examiners will also look for that. Yes. So this question is similar to that of previous question we saw in the previous slide, right? So this question is similar to that. Now, we have to translate the given chemical reaction or the given chemical word equation into chemical equations. Now let us see in detail about it. Hydrogen sulfide gas burns in air to give water and sulfur dioxide. Yes, this question has asked in 2016. So I think you can expect such type of questions in the board examinations. It has been repeatedly asked. Now, always write the word equation first. As I already taught you, write the word equation. Just write the reactants and products given in the sentence form. Then you can convert that into formulas, a normal chemical equation. So hydrogen sulfide, it burns in the air. So in air, what we have in air, we have oxygen, right? So anything it burns means it should have oxygen. So in the presence of oxygen only, no, it will have the capability to burn. So if they mention air, you need not have to worry. You have to mention that as oxygen gas. So it gives what? Water and sulfur dioxide. So what are the products here? Water and sulfur dioxide. As I already told you, the product has to be written on the right side of the equation. And reactant should always be placed on the left side of the equation. Don't get confused with these things alone. It's very important. It's a general chemical format. Now let me convert this into word. Not word, with formulas and symbols. So hydrogen sulfide, we should know the formula here. H2S plus oxygen. So as I already told you, it is a gas, right? So O2. Oxygen will always be in the form of molecule, right? In atmosphere, it is always in the form of molecule. So that's why we have to mention O2. Form what? It forms what? So it forms water plus sulfur dioxide. So how can we write the sulfur dioxide formula? Yes, O2. So 2 is nothing but di. That's why we are pronouncing it as sulfur dioxide. So this is what the entire equation looks like, right? So now how can we balance this? It's important that we balance it, right? As I already told you, we have to mention the number of atoms which are present on the reactant side and as well as product side. So if we take that here, look for the sulfur whether it is balanced. Yes, sulfur is balanced. We need not have to balance it. What about hydrogen? Hydrogen is again balanced here. Whether hydrogen is balanced here? Yes, even hydrogen appear to be balanced. It's H2H2, right? So hydrogen is balanced only, no? If you have any doubt, always count the number of atoms so that you won't get confused. What about oxygen here? Oxygen is had to be balanced. Here it is 2, but here it is 3. Here 1, right? So 2 plus 1, it's 3. So here oxygen has to be balanced, right? So mention here 3. So how many oxygen atoms we have now? 6. Do we have 6 oxygen atoms here? No. So how can we get those 6 oxygen atoms? Mention here 2. So 2 into 2, 4, right? Again here, if you mention 2 as a coefficient in the water molecule, before hydrogen, this 2 is also goes for oxygen, right? And this 2 is also for hydrogen as well. So when you balance your oxygen, you should also balance hydrogen. So now again you have to balance your hydrogen, because if you multiply the coefficient with subscript, 2 into 2 it's 4, right? So again you have to balance your hydrogen. So this is how we balance it. So it's very important that you balance the equation. If you leave it as such, then you won't get any mark. So balancing is very important. Fine. Now let us move on to the next subtopic, I mean subheading. Calcium hydroxide combines with carbon dioxide and forms something called calcium carbonate plus water. Yes. Now how can we write this equation? So here they have given in the word format itself. Now they expect us to pen down a normal chemical equation. So how we can pen down it as? It's very simple. So let us pen down it. So what is the formula for calcium hydroxide? As you all know, it's a base, right? Calcium hydroxide is a base, and carbon dioxide, it's acidic. Normally carbon dioxide is acidic, right? So let us write that now. So what is the formula for calcium hydroxide? CaOH2 hydroxide. So what about carbon dioxide? We all know it's CO2. What about calcium carbonate? It's CaCO3. And water we know. So now what we are going to do is we are going to present the same chemical equation which is written in the word into a normal chemical equation. The word equation should be converted into a normal chemical equation. So let us write that. CaOH2 plus carbon dioxide gives CaCO3 plus water. Now it's important to see whether the equation is balanced or not. So yes, if you see the calcium on the reactant side, whether it is balanced, yes, it is balanced. One calcium atom, right? So again it is balanced. What about carbon? Yes, carbon is also balanced one. Fine. What about oxygen? If you see the hydroxide, it's a combination of hydrogen and oxygen, right? So this 2 means what? Oxygen is 2. 2 oxygen atoms plus here, if you see, here 2 oxygen atoms. So totally 4 oxygen atoms, right? What about here? So 3 oxygen atom plus 1. Here 4 oxygen atoms. Yes, oxygen is again balanced. What about hydrogen? Yes, here 2, right? So 2 hydrogen atom, and here also 2 hydrogen atom. So yes, this is also balanced. And carbon, here 1 carbon and here 1 carbon. So again it is balanced. So this equation is already balanced. We need not have to balance this equation. Always check the number of atoms which are present on the reactant and as well as product side. Always make a table like LHS and RHS like that, make a table and write down the number of atoms present on the reactant side and product side. So this is how you have to balance, but this equation is already balanced. We do not have to balance this equation. So this equation is already balanced. Now let us move on to the next question. Yes, this question is the most repeated question in the board examination. It has been asked in 2011, 12, and 16. So what is this equation? What is this question is all about? Write an equation for decomposition reaction carried out with the help of electricity, sunlight, heat. Which means we have to write the example for decomposition reaction. So what and all reactions we know? And that reaction must make use of the sunlight, heat, or electricity. So let us pen down the chemical equations now and ensure once and twice the type of reaction which is being mentioned in the question. It's combination reaction or decomposition reaction. You have to know. And I already explained enough about decomposition reaction in the previous slides. Now let us write the chemical equations. Fine. Now let me write the equation for this by making use of sunlight as a medium. Let me take silver bromide as an example. Silver bromide, when it is kept in the sunlight, what will happen? What will happen? When it is exposed to sunlight, what will happen? It will decompose to form silver and bromine. So bromine, it will be in the form of vapor, basically. Okay, so it will be in gaseous state. So Br2, so it's in gaseous state. So this is what the reaction for sunlight. So silver bromide, it undergoes decomposition reaction and forms silver and bromine. We all know what is decomposition, right? So decomposition means what? A single reactant breaks down to form two or more reactant. Two or more products, not reactants. Two or more products. So now let me convert this word equation into symbols. So how can we convert this into symbol? First we should know the formula for silver bromide. It's nothing but AgBr. Now let me write the same equation it forms silver and bromine. So bromine basically it's a gas, it is in a gaseous state, so vapor, Br2. Now it's important that we balance this equation. Check out the number of atoms present on the reactant and as well as on the product. Now what about silver? Silver is balanced or not? Whether silver is balanced? Just see, silver is balanced, right? We need not have to balance the silver. But what about here, bromide? Here it is 2, but here it is 1. So we have to balance it, right? So we have to mention 2, not here. This is subscript. We have to mention 2. So now this 2 is also for the silver. Now we have to mention 2 here as well. Now this chemical reaction is said to be balanced. No doubt. Now this is balanced. So in decomposition, basically what will happen? A single product will decompose or undergo something called chemical breakdown and form 2 or more fragments. Fine, so this is all about one reaction. Now let us write about other reaction where they make use of heat as a medium. Now let us write the next equation. In the presence of heat, let me provide the decomposition reaction in the presence of heat. So what will happen if calcium carbonate is exposed to heat or subjected to heat? So it will form calcium oxide So it forms calcium oxide plus carbon dioxide. Now again we have to convert this into formula. So how can we write the formula? We all know, right? Calcium carbonate, CaCO3. So it is in the solid state. We all know. So when it is exposed to heat. So normally in chemistry the heat is exposed. The heat is mentioned like this. So this is a symbol to represent heat. Now it forms something called calcium oxide. So this is a symbol, not a symbol, but a formula for the calcium oxide plus carbon dioxide. So this is in the gaseous state, right? So this is calcium oxide, it is in solid state, and this is again in solid state. Now we have to see whether the equation is balanced or not. Yes, check the number of calcium atoms, 1, 1, it's balanced. What about carbon? It's 1, 1 balanced. What about oxygen? 3 oxygen atoms here. Here 2, here 1. So 2 plus 1, it's 3. So this equation is again balanced. We need not have to balance this equation, it's already balanced. So this equation is balanced. Now let us move on for third equation. It's very important. So we have completed with sunlight, heat. The other one is about using electricity as a medium. So first let me write, using electricity as a medium, we have to write the decomposition reaction. So how we can pen down the decomposition reaction? Here, electrolysis of water itself is an example for this. Now let me write the equation. So what will happen if water is subjected to electricity? What will happen? It's again simple. It will form hydrogen and oxygen, right? So these two are in the gaseous state and this is in the form of liquid. So should always mention the state, gaseous state. So let me pen down that in the form of formulas. H2O, right? So what is H2O? Again, electricity, H2 plus O2. It is in gaseous state, that's why I'm mentioning 2. So it will always be in the form of molecule, right? So that's why we have to write 2 here. Now, whether the equation is balanced or we have to balance the equation. Count the number of hydrogen atoms and as well as count the number of hydrogen atoms here. It is 2. What about here? It's 2. Okay, the hydrogen is balanced, you do not have to worry. What about oxygen? Whether oxygen is balanced, it is here O, here it is O2. Whether it is balanced? No, the oxygen is not balanced, so we have to balance it on the reactant side or product side. On the yes, we have to balance here on the left side. So what can we do now? We have to mention 2. So where we have to mention 2? So let me mention 2 here. So now this 2 is also for this hydrogen, right? Now how many hydrogen atoms are there? 4. Because you have to multiply the coefficient with subscript, right? So it is 4. Now this oxygen, this 2 we have mentioned for oxygen, right? And this 2 is also for hydrogen. Now we should also balance the hydrogen because now it is 4, right? What about here? The hydrogen is only 2. So we have to mention here 2. Now this equation is balanced or not? Check the number of hydrogen atoms. It's 4 on the left hand side. On the right hand side it's 4. What about the oxygen? Yes, it is 2. What about the oxygen on the right hand side? Yes, again it's 2. So now this equation is balanced. So this is how you have to write the example. Sometimes they might ask question like this only. Sometimes they might give you the word equation and ask you to convert that into a formula. So you have to be prepared for all the type of questions. These are very simple equations. So whenever they have asked such type of question, ensure that you mention these 3 examples because all these 3 examples are very simple examples. You can also make use of magnesium oxide in the place of calcium carbonate. Even magnesium oxide can be used as an example for, it's one of the decomposition reaction example. So it forms magnesium and oxygen. And if you couldn't able to remember that, you can make use of calcium carbonate and calcium oxide, this reaction. That's it. Last question. A blue color salt becomes white on heating. Give reason for the above observation. What happens when we add water to the salt which was obtained after heating? Fine. So this is the question all about, right? Now, again, if you see the question, they didn't reveal the compound name. Can you able to see? They didn't reveal the compound name. See, they have just mentioned blue color salt, but by now, I'm sure that you guys would have found the salt name. Yes, it's copper sulfate. Now, they are just talking about a small experiment here. So what happens when the copper sulfide is subjected to heating process? The color becomes white. We have to explain why the color is turned to white. And what happens when we add water to that salt again? Whether we can able to see any color change, we have to mention that. Now just take a normal blue color salt. So here blue color salt, as I already told you, is nothing but copper sulfate. But here we have to talk about this properly. It's nothing but copper sulfate pentahydrate. This is a compound name. Penta means 5, hydrate means nothing but it's water. So hydrate is nothing but water, penta is nothing but 5. Now we have to write the formula first. First, always give lots of importance for the formula. Okay. Now it's important that we write the formula, then we can go ahead with the question. So how can we write the formula? Just write the general copper sulfate formula. CuSO4. So this is the copper sulfate formula, right? Even in previous slide we saw about this. And how can we write this pentahydrate? So hydrate here nothing but we have to write the water. H2O is water. If it is penta, how can we write this penta? Penta is nothing but 5. So just mention here 5. That's it. So this is how we have to write the molecular formula for copper sulfate pentahydrate. So whenever you talk about any compound, ensure that you mention the formula. It's very important. So this is how we have to mention the formula. Now, we can also write this formula in a different way. You know how? Let me write this formula. See. Now, how can we write this formula as? Write the same CuSO4, right? So this is how we wrote before. Now let me write the formula again, but in a different way. How can we write the same formula in a different way? Okay, just multiply this. 5 into 2 is 10, right? So how many? First write the copper, then 5 into 2 it's 10, right? Just multiply the coefficient and subscript of hydrogen atom. What will happen? 10. So write the H and mention the 10 in the subscript. Then, what about sulfur? It's only 1, right? Just mention here, just 1. What about oxygen? Here it is 4. What about here? So here this 5 is not only for the H but also for O. So there are 5 oxygen atoms. So here 4 oxygen atoms. 5 plus 4, it is 9. So just put oxygen symbol here and mention 9. So this is other way of writing copper sulfate pentahydrate formula. Done. Now let us get into the question back, because we found the compound, right? So now we have to subject this compound to several process. So let us see that. Now let us see about this. Now we found the compound name. Now I'm going to subject this compound to heating process. So let us see what it happens. So I think you are comfortable with the formula now. So let me go ahead with the process. So just now we saw the copper sulfate formula, right? Still, let me write here. We all know the color of copper sulfate. It's blue color. So let me take the blue color itself so that you can understand better. Copper sulfate pentahydrate. Or we can also call that as hydrated copper sulfate. So there are many ways of calling it, and there are many ways of writing this molecular formula. I just now showed you the sample, right? Fine. Now what we can do here? Now it has been subjected to heating. So heating, this is a representation of heat symbol. So it's basically a heat symbol. It is a representation of heating. Now what will happen if this compound is subject to heat? Actually, this is blue color, right? Normally it is called as blue vitriol. This compound is also called as blue vitriol. Now, what will happen if this compound is subjected to heat? Fine. Now what will happen to this compound? We have to write copper sulfate and water is just removed out of it. So water gets removed. That pentahydrate, right? That water gets removed from here. So here what is happening? The blue color copper sulfate has changed into white color. So the blue color copper sulfate has changed its color to white. Why there is a color change? Because on heating, the water is lost. The water is lost from the copper sulfate pentahydrate compound. That's why the blue color turned into white. So this is the color of anhydrous copper sulfate. So this is a color of anhydrous copper sulfate. So this is how the color will be. It will be white in color. Hydrated copper sulfate will be blue in color, but anhydrous copper sulfate will be white in color. Once the water is removed, it will be white in color. Now again, when this blue copper sulfate is subjected to heating process, what will happen? What will happen now? Again, it will be in the form of white color only, because when you subject copper sulfate pentahydrate to heating, it will form a white color copper sulfate compound. It's an anhydrous form. It's an anhydrous form. Now we have satisfied the first layer of the question here. See, we have satisfied. Then read the second layer of question. We are ready to address it. What happens when we add water to the salt which was obtained after heating? Now, this is a salt, right? Now I'm going to add water to this salt. What will happen if I add water to this salt again? What will happen? Whether we can able to experience any color change? Yes, we can able to see a color change. What will happen if a white color? What will happen if a white colored anhydrous copper sulfate is white in color, right? Now again, if you add water to it, what will happen? We're just adding water to it. What will happen? Again, it will combine and form a blue color solution or a blue color salt. It's nothing but blue vitriol. It's another name for hydrated copper sulfate, right? It's another name for hydrated copper sulfate. So on subjected to heating process, what will happen? It will lose its color. Again, if you add water to it, it regains its color. It's very simple. And this question has been repeatedly asked in 2011 as well as in 2015 board examination. So it's very important question. So they might ask you like this question again and again. Be prepared for all these questions.